These brilliant colours of the natural world have inspired the development of a unique material, and fashion designer Amy Winters has already caught on.
This type of colour is found in materials such as the morpho butterfly and beetle wings, and also fish underwater. The material actually starts to contort to your body shape, so depending on how you move, the material starts to have a completely different type of colour.
For centuries, fabrics have been coloured by chemical pigments, some highly toxic. But this extraordinary material generates its own colour from its own structure. It's called polymer opal, and it was inspired by a stone.
This is an opal that was dug out of a mine in Australia. It's iridescently coloured. You can see it has different colour play. And this has always been interesting for people in the fashion industry. Part of the reason it's expensive is it's rare. So we haven't got a way of making things like this until now. So what we're interested in doing now is to make materials which show those same properties.
Studying real opals in his lab, Professor Jeremy Bornberg observed rows of evenly spaced glass spheres. He realised that the arrangement of these glass spheres was the source of the opal's changing colours.
So what's an opal? So let's imagine that we take a whole lot of oranges and we try and stack them up together. Only we haven't really got oranges, they're 1,000,000 times smaller. They're tiny, tiny spheres of glass. And what we have to do is we have to actually stack them in a perfect sequence. So if I do that with oranges, that's not so difficult. I just put them in lines like this. The way that the opal works to actually give these amazing colour effects is just because of the regularity of the stacking. So each of these spheres is about half the wavelength of a particular colour of light. And if it's transparent, the light bounces through and then bounces off the back side. But it also bounces off the top side as well. So we have all of these waves of light which are adding up with each other.
Jeremy knew that microscopic glass spheres would be impossible to manipulate accurately, so he manufactured his own plastic spheres.
We take essentially plastic bags, which are completely transparent, and we chop them up, and then we have a process where we can actually extrude them, where suddenly, when they become ordered like this, they start having a colour.
To do that, he squeezes a mass of plastic spheres into a tape.
So this is the tape we've just produced from the extruder, and now it's just a mass of nanoparticles, not in any particular arrangement. So the first thing we have to do from this is to make a film. And I can show you sort of what goes on like this. So these are our spheres. That's sort of disordered. But if I just shake them around, then what happens is they start to form a really nice lattice, just like the oranges on the stall. If we shake them in the right way, we get perfect ordering, and then we get a beautiful green or a red colour from the light scattering through this structure.
As he heats and flattens out the tape, the microscopic particles are squeezed into an ordered interlocked position. The play of light through the spheres produces the structural colour.
And in fact, we can loop it round a number of times, and when we go backwards and forwards, what we get is a film that looks something like this. So you can see it's already much greener. That's because all the spheres are now really locking into their nice positions. That's what makes the polymer opals.
The colour of the polymer opal depends upon the spacing between the spheres.
So if you stretch them, they change colour because the spacing between the spheres changes. So this is something the fashion industry has never had. And whenever we show it to people who make clothes, they're desperate for it.
What I find particularly exciting about this type of material is not only the colour change. I mean, it's great that it can change colour, but the fact that it's so flexible and the potential it offers for the future and the design ideas which you could incorporate into this type of material are endless. It's closer to who we are as human beings, and it starts to stretch a bit like our skin. You can start to have clothing in unusual shapes, and each bend and twist of the material will create a different effect. The imagination is your limit.
With the potential to revolutionise how we produce colour in everything from banknotes to bras, Jeremy's polymer opal could make toxic chemical pigments a thing of the past.